Okay, today we're gonna do a system of linear equations, and we're gonna solve for the solution of the system of linear equations. So today we're gonna use the method of substitution. System of linear equations. Okay, well, you could have two, you could have three, you could have many equations. In our case today, we're only going to deal with two. And as you see inside the word here, linear, that would mean line. So lines, all of these equations are equations of lines. And you're familiar with the form of a line, equation of a line, mx plus b. Okay, but they don't always come like that. You could have y minus mx minus b equals 0 or something like that. And you're going to see there's all kinds of forms that it can come in. But the key to all these, to know that it's a line, is you have to have the power of the y must be to the first power, and the power of the x must be to the first power. Okay, these m and b are just constants. And you say, well, what's a constant? Well, constant is something that stays constant. So what number would that be? So they're just numbers. Okay, so like 3 or 6, that's 3 is always 3, so it stays constant, so that's a constant. And there's 6, that's a constant. They're just numbers. So and you remember from your study that this is the intercept and this is the slope. Okay, the slope of the line. And if you have a positive slope, the line is going upward. If you have a negative slope, the line is going downward. If you have zero slope, that's m equals 0. See, m equals negative. Okay, m equals positive. Okay, and what about this? Well, that would be m is infinite, and we typically say that's undefined. Okay, that wouldn't be a function, because you would have multiple points of y for one x, and you can't have that. You have to for anything to be in a function, you have to have one y for every x. Okay, let's look at an example here. And substitution. Okay, substitution is where we're going to take one of the x or y, and we're going to put it into the second equation. So let's give you a system. Let's see what a system looks like. So here you have y equals 6x minus 1, 11 rather. Okay, negative 2x minus 3y equals negative 7. Okay, well, this is your system. You have two lines. This is a line, and this is a second line. We don't know if these lines cross. They could be parallel. They might cross at one point, or they might even lie on top of each other. Okay, that is going to dictate many things that we can talk about. But today I'm going to just kick off this first video of a series of a few videos about the systems solving. Okay, system of linear equations. This method by method of substitution. Okay, well, here's your equation 1, and here's your equation 2. So I'm giving them names. Now, we could solve this equation for x or y, and then put it in the top equation, x or y. But why would we do that? We already have the top equation is solved for y for us. Okay, so we're going to take what's given, and we're going to use this value and push it right into equation 2, into the y. So let's try and see how that works out. So I'm going to tell my teacher what I'm doing. Equation 1 into equation 2. That's what I'm doing. He knows. Okay, so I'm going to write equation 2 again. Minus 2x minus 3y equals negative 7. Okay, now we're going to take this value that I have here, I'll underline it, and we're going to put it in. This y is going to go right into here. We're going to dump all that, what that's value is, into this equation. That's the substitution. We're substituting what is y, but this is what it is here. Okay, it's 6x minus 11 into the second equation. So we're calling this a sub E1 into E2. That's what we're saying. Okay, minus 2x minus 3 quantity 6x minus 11 equals negative 7. There's my substitution. It's done. Now, this is not equation 2 any longer, so I'm going to give it another name, equation 3, because this equation is actually a combination of 1 and 2 together, so I'm giving it a new name. Okay, so let's use our distribution principles here, and we get 2x minus 18x plus 33 equals negative 7. I'm just solving this out now. Okay, so I multiplied negative 3 times 6x, negative 18x, and the negative and the negative will cancel each other to become positive. So we have 33, and then we have that the right side of the equation stay the same. A lot of kids get confused and they write the equation equal sign and they move stuff around before they even get to doing it properly, and they get the wrong answer. Okay, collect like terms. Well, we got these two guys on the same side, but we got to move this guy over to the other side. Okay, so we can collect the like terms. So to do so, well, let's do it in this step here. Minus 33 minus 33. I'd like to draw a line and add the two equations. All right, so let's add these two guys. So I get negative 20x equals now negative 40, okay? And we have to divide now to get rid of that negative 20 on that side. So we divide both sides by negative 20, and this just becomes x equals positive 2. So that's the value, one of the solutions. Now, to get the y, we're going to substitute this x value back into either equation 2 or equation 1. And because now, by the way, I'll give this a new name. I'll call it equation 4. So there you go. Now you got this is really equation 3, but it's been sort of worked on. It's been advanced. So I'm giving it a new name, equation 4. So I'm going to tell my teacher what I'm doing. Equation 4 into equation 1. There you go. Now he knows what I'm doing. So let me rewrite equation 1. I have 6x minus 11. There's my equation 1. I am going to put equation 4 now, which is the x value, right into there. So I get 6 times 2 minus 11, and there's y. Okay, 12 minus 11, and what is that? Y equals 1. So my solution set here, the solution, is a single point, okay, where these two lines meet. Okay, I don't know the exact graph of it, but it could be like this and it could be like this. This is the point where line 1 and line 2 are both living at the same time, and they have a solution there. That's called the solution. All right, is the point where they actually both are existing, and that's what's referred to as the solution. Okay, so the solution point is 2 plus 2 plus 1, and it's 1 point. Now, we notice these slopes are different. They would be different in this case, okay, and I want to say another thing about this. We have a terminology is when you get an answer. Okay, we got an answer. So that would mean it's consistent. So you say to your teacher, this is a consistent solution. Okay, and because there's only one solution, you say it's independent. Okay, so it's consistent, independent. Okay, and that's the end of this video. Thank you.